I've mentioned too that water is absolutely critical. So not only are you a majority made up of water, but we also look at on the Earth's surface, 71% of Earth's surface is water. If we actually looked at your body weight, take your pounds, the number of pounds that you weigh, multiply it by 0.66 or 66%, and that will tell you how much of you is water weight. Those are huge numbers, right? So we've got to deal with this water. And we'll talk later on about the fact that for a long time, life was only found in water on this planet. So, very important. When we look at properties of water, there are a couple of things we have to consider. We've already mentioned this idea of surface tension. I told you it was because of hydrogen bonds, holding water molecules together between the positive and negative of two water molecules, right? So when we look at holding these together, the surface tension, it's also known as cohesion. Okay? Cohesion is the joining of two like molecules, or two of the same molecules. Okay? We talk about water having a terrific capacity to absorb and retain heat. You know about this if you've ever been in a swimming pool in the summer. The swimming pool water heats up during the day. It gets very, very warm. The sun goes down, the air gets chilly, but you get into that pool and it feels fantastic. Warm, holding in that heat, terrific. Less dense when solid than liquid. What's the street term for this? Ice floats. Water is something we refer to as a master solvent. This seems very special in some way, but all we're saying is that a solvent actually wants to dissolve things. You dissolve a lot of things in water, don't you? Think about it. Salt and sugar and all kinds of things. Next time you're in your kitchen, think about what you stir into water and what dissolves because of it. Hydrophilic and hydrophobic interactions. These are critical to the formation of your cells. Philic means like, phobic means hate. Hydro is water. So molecules that are hydrophilic are water likers. Molecules that are hydrophobic are water haters. We're going to have to deal with these in your body and in the rest of the environment in which you come into contact. So cohesion, we mentioned, the same kind of molecules sticking together. Adhesion is actually the sticking together of two different kinds of molecules. So I remember this one because of adhesive tape. Means I'm sticking two things together, right? It helps me remember. I don't know if it'll help you or not. Give it a shot. But we look at this property. So these hydrogen bonds, these dotted lines we've talked about before, are going to hold the water molecules together. We know that. But what we're also interested in is this bond right here. This is actually the inside of vascular tissue of this tree. This is the vascular tissue. Vascular tissue is like circulatory tissue for you. It's going to move water, it's going to move nutrients, sugars, food, and so on for the plant. The water itself, the water molecule itself, is actually going to bond gently, very gently, with the sides of this plant wall. So when we look at this little dotted line here, this is actually adhesion, because it's between a water molecule and the plant cell wall. The hydrogen bonds between two water molecules, that's cohesion. Okay, so two differences there. We'll have to look at these a lot in nature because we've mentioned the leaf floating on the surface water. But when we look at this guy, our little water strider here, why is it that he can sit on top of that water? Why is it that water forms droplets? The desire for water to stick to itself is extremely high because of that positive and negative associated with the water molecules. Very, very important. This will be important inside you, and as you can see here, it'll be important in the environment as well. This is also the reason that you can slightly overfill a glass of water and it won't spill. Try this at home. Fill up a glass of water up to the very top, and then very, very slowly with another glass or a measuring cup or a spoon, slowly add water to that glass until the water just begins to form a dome above the rim of that glass. This is why that happens. Now, if you fill too much, it spills. But if you are very gentle, you can actually get the water to go higher than the rim of the glass. It's fun. So we mentioned this idea of cohesion and surface tension. Great. Okay. The idea that water holds a large amount of heat, we've mentioned as well. We've got to think about the fact that heat is actually energy. Okay, so, and it's the energy associated particularly with atomic movements. So we'll look at heat a lot in the systems. And when we look at temperature, temperature is a measure of heat intensity. So how much heat is there? Temperature is that increase in heat intensity over time. So we have to actually look at the fact that water holds a tremendous amount of heat. And that's actually why when you sweat, you cool down. So you're sweating, water moisture collects on your skin, and as that water evaporates, it actually is taking heat with it from your body. That's pretty cool. We also mentioned the idea that ice is less dense than water, or ice floats. So water can exist as three phases, and we see it in three phases on this planet: gas, liquid, and solid. So when we look at water as being less dense as a solid than a liquid, it's because of that hydrogen bonding. And I'm going to show you a diagram that shows you why this is. But when we look at the fact that ice floats, we have to think about what that means for the molecular structure. And what that means is, as liquid water, we've got a lot of movement of these atoms, right? A lot of movement of these water molecules around. And of course, if you heat up water to an extreme, it's going to actually turn to steam, right? So you've done this. Boil water on the stove. You can watch the water come off the surface as steam. It's still water. You haven't defied any sort of laws. It's still water. It's just in a different form. However, if you freeze water, it actually expands. You know this if you've ever put a water bottle in the freezer and forgotten about it. You come back, the water bottle is all blown out. Sometimes the cap is missing. Sometimes the bottle cracks, right? Because the water has expanded so far. And what we're doing is actually relaxing those hydrogen bonds between the water molecules, and the molecules spread out. And when they spread out, they're actually forming a very different density for this compound than as a water state. This is critical for aquatic organisms. If ice didn't float, if ponds filled clear to the bottom with ice, organisms wouldn't be able to overwinter. So with ice floating, and in this case I show you these little shrimp that are actually feeding. You can see the green in their guts. They're actually feeding on algae that's growing on the underside of the ice. So it's setting up an ecosystem to sustain them over the winter when there's little food available. And of course, because all the shrimp are eating on the underside of the ice, who else do you think is going to eat here? Well, fish that eat the shrimp, right? And then whales that eat the fish, and so on and so on and so on. So it sets up this terrific community structure, all because ice floats. I mentioned to you the idea that water is this master solvent. Okay, solvent is what we refer to loosely as the dissolving agent, the thing that's actually doing the dissolving, and the solute is the something or the substance that is actually dissolved. So when we look at these guys, we're going to look at a solute being dissolved in a solvent to form a solution. Got that? So if I tell you I have an aqueous solution, what does that tell you? It means I have a solution whose solvent is water. Always. So in this case, we've got water molecules, we've got our sodium chloride that we talked about before. Water's moving in here trying to break up sodium chloride. We see this all the time. You do this in your kitchen. It's not violating any laws. You're simply dissolving salt in water. Okay, so what in this case is the solute, the solvent, and the solution? Solute is the thing being dissolved. What is being dissolved? What is doing the dissolving? What is the solvent? So then what's the solution? Salt water, right? Water is extremely good at doing this because of that polar covalent bond that is water, right? We said with the partial positives and the partial negatives of water, these are pretty cool things that we've got to look at. And in the meantime, we've actually formed, in this case, our salt water. Because of that polar covalent bond of water, it's able to break up the sodium and the chloride. It isolates it, breaks down the sodium chloride, and you end up with salt water in the end. Now, not everything will behave with water like this. We've talked about the idea that hydrophobics are water haters. So things like oils. Okay. Now, we said before that water is a polar covalent bond, right? This means that water is a polar substance. So nonpolar means that you have a nonpolar covalent bond and a nonpolar covalent bond gives you things that would be hydrophobic, things that don't like water, and in this case, oil, right? So oil floating at the surface, oil like in your salad dressing. We see all this all of the time. So hydrophilic is any molecule that will interact with water. And it would be polar. Hydrophobic will not interact with water. So what will it be? Non-polar.